I've recently been thinking about why we use update children instead of lots of set value instructions. I'm guessing it has something to do with data consistency.
Frank said he was just talking with somebody else about consistency issues. Want to see if I can find him?
Yes, but I've got a doctor's appointment to check out the medical side effects of truth-seeing amulets. The developer's free, though.
Yeah, you should come over.
Want to take the company sailboat?
Hello and welcome. I'm here with Puff, an engineer on the Firebase team, and we're here to talk about how to keep data consistent in Firebase.
Yeah, that's going to be fun.
So Puff, I get how you do initial design, but how do you ensure that your data can remain scalable afterwards?
Yeah, that's a good question. It's always tricky, right? When we do the initial data design, lots of software engineers are database modelers by education. So we try to minimize the duplication of data. We go through all our database normalization forms. And then we notice things don't scale up very well, and we need to start denormalizing a bit. So in Firebase, that pretty much comes in the form of duplicating data. So instead of having one place where you store a bit of data, you actually store it in every place where you might need it. So if you have a chat application, for example, you have a list of messages and a list of users, and every message belongs to one user. So it's very, very natural to want to just store the ID of the user and look the user up. But that means that every time you need to display a message, you need to look up the user that the message belongs to. And it might be easier to actually store the minimal information you need to display for a user, like the username, next to every chat message. Because then if you want to show a list of chat messages, you just load the messages and you don't need to do a lookup yet. So that's a very common thing we see, and this is data duplication. It's not very natural, but it's how you can keep your data scalable.
Puff, would you explain what atomic updates are versus the opposite sort of method?
Yeah, sure. So the scenario we just had, where you have a chat room and you have the user separately, but you keep the name of every user with the message that they post. And let's say that the user wants to change their name, right? So the first thing you need to do is that you update the username in their user profile, but then you need to loop through all chat messages and update the names there. So the simple way of doing this is actually, right, you first update or set value on the user profile, and then you find all the messages that they have and you loop through them and update them one by one. That works great. The problem with it is that if somewhere in the middle the user closes the Android app, then you have, there will be no more updates being sent, and you have half of the messages updated and the other half won't be. And that's what atomic updates solve. So with atomic updates, we built the entire, both the changing of the name and the fanning that data out into every chat message. We put that in a single command to the Firebase database. So that command can be pretty big, but it's either going to completely succeed or it's not going to happen at all. So this is very beneficial if you're updating duplicated data.
So what are the major ways that people keep data denormalized in the world of Firebase?
It's mostly about duplicating data. So I often tell people to model screens in their Firebase. So the information that you need in a screen, try to get that into one location or as few locations as possible in the database. And so that's what we had before with the chat application, right? Where you store the username with each message, even though you also have their name in the profile. And you will see this quite often. So we see people, if you're having a list of bank transactions, for example, you might want to duplicate the credit card information for every bank transaction. So this is one where we see it quite often too. And essentially they're all variations on that same theme, where you duplicate the data into multiple places so that you only have to read fewer locations.
So Puff, are there any times when you can't use atomic updates?
Yeah, there are. So atomic updates, right? The update either makes it to the Firebase database or it doesn't. So there's no inconsistent state that you can have. We have one other way of doing that. That's when you use a transaction. And atomic updates and transactions, they are sort of similar, although they are completely different APIs. Why you would want to use a transaction is if you also want to get the previous value in there. An atomic update can write to multiple locations, but you don't know the current value on any of the locations. If you need to know the current value, for example, if you are going to increase a counter or keep the balance of an account, then you need to still use a transaction. You can't use atomic updates.
So I just want to make sure on this one, Puff, and just make sure a developer really understands this one. Are there any other limits to atomic updates that we should know about?
Not atomic updates per se. One of the things I think in the course we focused a lot on using atomic updates from the Android client, and they work great there. But as you're updating more data, your update command, the network traffic, will get bigger. So there's a certain limit where it's not a good idea to do this from a client anymore. If you're building a social media app, then if a user on your app has 1 million followers, then probably you don't want to write all that duplicate data from an Android device, because it just becomes too much data that you're sending. So in that case, you most likely want to still use the atomic updates, but you want to use them from a server. It's still the same mechanism, you still use the same API, but you're moving it off of the client device to an environment where you have probably better network connectivity and more memory available.
Oh, that makes sense. Well, Puff, thanks very much for your time. I really appreciate your help.
Sure, you're welcome.
I think it's going to really help our developer out.
Cool, that's why we're here.
All right, thanks a lot.
Sure.
All right, cheers.
Now let's hit the pool.
Okay.